Hello, my name is Richard Patterson and I'm a network architect at Sky UK. About 5 years ago, I spoke at UK NOF about how we had just finished building and launched a brand new greenfield fixed line broadband network over in Italy for Sky Italia. I covered how we were using unbundled GPON in the access network, EVPN to carry frames across the metro into the core, where we had segment routing over to the BNGs, where we do subscriber termination. I briefly there touched on using MAP-T for IPv4 as IPv4 address sharing. That network's been growing quite well over there. We have almost, not quite 100% of all subscribers over there using MAP-T. It's been working well, so we've now decided to bring MAP-T over here to our existing UK network. And deploying MAP-T in a brownfield deployment is a bit different to how we did it in a greenfield deployment over there. Those differences we'll get to in a moment, but before that, a very brief recap of what MAP-T is. It's one of 5 IPv4 as a service technologies, and these are generally just it's a term for delivering v4 using v6 infrastructure, and they all have the capability of delivering IPv4 address sharing. They can be grouped by those that do translation and then those that use encapsulation for the data plane, and then those that do translation can be distinguished by which ones are doing stateful translation or stateless NAT64, and then which ones are using more traditional stateful carrier grade NAT style of address sharing, or those that are using the new stateless address plus port algorithm-based address sharing. There is RFC 9313 to help you evaluate all the pros and cons to work out which one suits your use case best. MAP itself comes in both flavors, encapsulation and translation. Encapsulation has more per packet overhead because you're whacking a v6 header on top of the payload, but that IPv4 header remains intact when it pops out and gets decapsulated on the other side. MAP-T, you're translating the v4 header to a 20-byte v4 header to a 40-byte v6 header, so there's fewer bytes of overhead, not zero, but that layer 4 header remains intact for doing any 5-tuple hashing or anything. And because that layer 4 header remains exposed, and you don't need to decapsulate an additional IP header, you can do things like you can predictably address CDN servers and other servers and serve IPv4 only eyeballs from IPv6 only servers. So the Italian network was, as mentioned, greenfield, so we went to RFP for everything, including the BNGs. So when we did vendor selection on the BNG, we chose one that could do MAP-T border relay function on the device. In the UK, our BNGs, we already have BNGs, they don't support the border relay function, so we've gone for an off-box solution hosted elsewhere in the network. And the Italian network was greenfield, so we could do cool things like use segment routing, we could use EVPNs and segment routing. The UK network is existing more of a traditional service provider network. We have targeted LDP pseudo-wires to get the frames across the metro, straight to the BNG, and then 6PE across the core to the border relays. The MAP border relay solution itself is actually a 2-box solution. So we have the absolute majority of traffic being translated by a Cisco ASR 9903, which is Lightspeed Plus based. But there's it's about a percentage of traffic that needs special handling and is punted off box to what we call an exception handling device, which is the Catalyst 8500. There's plenty of packet types which could be considered as exception traffic. We're quite lucky with the ASR 9903. It can do most things in hardware on the Lightspeed Plus. The only packet types that need to be punted off to the Catalyst 8500 are packets that are too big that need fragmentation, and packets that are already fragmented and need reassembly before they can be translated. So depending on your vendor selection, you may want to evaluate this list. So fragmentation, I mentioned you're swapping a 20-byte v4 header to a 40-byte v6 header, but there's also the potential of an extra 8 bytes for an IPv6 fragment header if the original v4 packet was already fragmented. So you're going to need a 1528 byte MTU to avoid any of the additional fragmentation incurred by the translation. Sadly, we couldn't guarantee 1528 bytes across our entire access network, so our wholesale access provider officially only supports 1500 bytes, so we've had to use that as the lowest common denominator in the UK network, which means you're going to get more fragmentation, but we're going to get more fragmentation and additional processing on both the CPE and the border relay, but there are things you can do to help try and avoid that, like reducing the TCP MSS value or relying on path MTU discovery. In the UK, our network is built around 4 centralized supercore POPs where we have a pure P-layer, BGP-free P-layer in those 4 sites, and these MAP border relays are hanging off that P-layer as PEs. Depending on how the IPv4 traffic evolves over time and the ratio, we haven't quite decided yet whether we will scale the border relays horizontally at those 4 centralized sites, or we'll deploy additional border relays deeper into the network at additional satellite POPs where we also have BNGs. It doesn't make sense to go any deeper into the network, into the metro or beyond, because packets need to be routed via the BNG anyway. Because MAP-T is stateless and doesn't need to keep track of all the flows and signal them between different devices, we can use anycast for resiliency. So we will anycast the v6 prefixes southbound towards the subscribers to the BNGs, and we'll anycast the v4 prefixes northbound to peering transit, CDNs, the internet. And so flows can be asymmetric and go via any or all of these border relays, and it doesn't matter. And now, because it's stateless and because we're using anycast, we can also use ECMP for load balancing. So multiple flows to the same subscriber can be hashed differently and go via different border relays. This did identify a problem within our network, and that our peering transit vendor hashes fragments differently. So the initial fragment with a layer 4 header will get hashed one direction, in this example up via Telehouse London. But then subsequent fragments that don't have a layer 4 header will get hashed differently and go to a different border relay and cannot be reassembled for translation. This is probably the main reason why we haven't quite got to 100% coverage of MAP-T in Italy. Not because we don't use anycast over in Italy, but the same hashing algorithm is generally used on a device for all types of hashing, so for cross lag bundle members, for example. So the packets, the fragments in Italy will definitely land on the same border relay, but they may land on different line cards or different ASICs, or even just arrive out of order. We've mitigated this issue in the UK. We've gone around these problematic devices and enabled layer 3 only hashing, and hopefully we'll get to go back to Italy at some point and do that and finally be able to turn off DHCP4 over there. So the anycast doesn't just follow the IGP best path, shortest path. We've got BGP policies to direct packets towards the most optimal border relay. So when subscribers are terminating in those 4 centralized POPs on the BNGs there, then they'll prefer the border relays that are local to that POP. If that were to fail, then flows will fall back and evenly across the remaining 3 border relays at the other 3 sites. And if we do go distributed, then the additional border relays at those distributed satellite POPs will become primary, and if they were to fail, then packets will go to the 2 parent sites that that satellite POP parents to. To help visualize that, subscribers terminating in a BNG in Telehouse London would normally use the Telehouse London BR, but it fails, so the flows evenly distribute across the remaining 3 sites. And subscribers on a BNG and a satellite POP would prefer both Telehouse London and Brick Lane if they were active, but Telehouse has failed, so Brick Lane picks up the slack. And if we do decide to go distributed, that border relay will be primary. It fails, so the 2 parent sites pick up the slack. Now, The statelessness of MAP-T is great. It means we can buy cheaper, more scalable hardware. It means we can use Anycast for resiliency and ECMP for load balancing. But that complexity has had to have gone somewhere. It's gone out of the forwarding plane. It's gone into, it's not a control plane as such, but what I call the administrative plane. So unlike traditional stateful CGN methods, which can dynamically and efficiently allocate ports to a client as required, MAP-T gets its statelessness by having a predetermined algorithm and configuration rules that bind a user's v6 prefix to a v4 address and port set ID. So the sharing ratio is fixed, whether you've got 0 customers or 8 customers in this example. As soon as you configure that rule, you've consumed your v4 addresses. In UK, we're using an 8-to-1 sharing ratio. So by default, all of our customers in MAP-T will go to that 8-to-1 sharing ratio profile, but we've built 2 processes to allow a customer to opt out of address sharing. Well, we put a lot of effort into building an automated or proactive opt-out path where we will listen to notifications that are sent by the CPE, the SkyHub, or by the MySky app when a user toggles UPnP or enables DMZ or does any port forwarding. And we'll use that as a signal to apply the opt-out profile. And we will have to disconnect the customer because the customer needs to reconnect to obtain a new DHCP-v6 PD lease and get a new prefix and new MAP-T rules. There's also the reactive process where a human can do this as well via the call center. So we're still using MAP-T to deliver IPv4 as a service. They just have a whole IP address to use themselves. We're not disabling MAP-T entirely as part of this. We do have that capability to disable MAP-T on a per-line basis, but generally it's only reserved for cases that are fundamentally broken with MAP-T, which we have had to use, sadly, a little bit recently because of some fragmentation issues, but hopefully we'll fix that soon and no longer have to use it. So yeah, the complexity being in the admin plane. You've previously with v4, we had very granular v4 pools, and we had to use automation to add and remove and shuffle them around to get the most efficiency out of it. But for v6, we didn't do that. We just provisioned a stupidly large IPv6 pool, shove it onto the DHCP-v6 server, and didn't have to worry about automation at all. If we were to do that in the MAP-T world, then we'd be burning a whole bunch of IPv4 addresses that we can't afford to do. So we've had to make our DHCP-v6 pools much smaller and granular now because that's a fixed sharing ratio to v4, and that kind of requires automation now so that we get the efficiencies we require. We use port-based authentication. Means we don't pay attention to any usernames or passwords or anything. We rely on information that is inserted by the access nodes, by the DSLAMs or the OLTs, and to specifically the remote ID, which is into DHCP-v6 option 37 or v4 option 82.2. In dual stack, either DHCP-v4 or DHCP-v6 can trigger authentication, but for MAP-T, we need DHCP-v6. We rely on DHCP-v6. In Italy, it was a greenfield network. We had no legacy technical debt. We knew that all the CPEs we're shipping to customers supported MAP-T, so we could enforce the use of MAP-T. In the UK, it's more of obviously it's a brownfield network, so we have a whole bunch of devices out there that don't support MAP-T. So we're being a little bit more pragmatic with the enablement approach. So we will listen for clients to connect to the network and ask for MAP-T before we give them MAP-T. They ask for MAP-T by including option 95 in the option request option of a DHCP-v6 solicit. If they do that, that instructs our Radius platform to return the right DHCP-v6 pools to give them MAP-T. However, during trials, we identified there are a bunch of third-party devices out there that don't support MAP-T, but still ask for MAP-T. So they still include, suboptimal. So the main culprit for this is OpenWRT's DHCP-v6 client. The good thing is that OpenWRT does support MAP-T, it's just the MAP package isn't installed by default. So thankfully, users can package update and install the map package over v6 only, so they can do that and fix their v4 connectivity. Long-term fix, there's some PRs in there trying to get the OpenWRT maintainers to change the default behavior of it. Ubiquiti's Unify is another prolific device out there, and it also uses the same DHIPv6 client. However, it doesn't support MAP-T. If we fix the default behavior in OpenWRT upstream, hopefully they'll inherit that fix at some point. But at the moment, the only proper fix the only real fix a user can do is disable IPv6 to force DHIPv4 authentication. Or you can reach out to me or go escalate via the call center to disable MAP-T if you want. So we rely on DHIPv6 to configure and enable MAP-T. However, only about 70% of OpenReach's network actually supports lightweight DHIPv6 relay agent, or LDRA, that inserts the information we require for authentication. So for the remaining 30% of our footprint, we have to rely on DHIPv4 to bootstrap authentication so that then DHIPv6 can follow along afterwards. We obviously don't want to burn any more IPv4 addresses than we have to, so for these bootstrapping sessions, we only assign private RFC 6598 private address that's not usable. DHIPv6 option 95 doesn't exist in DHIPv4, so we had to get creative. We already use option 60 or vendor class ID for some other things, so we've appended the MAP-T string on the end of that option to allow us to signal that this CPE supports MAP-T within DHIPv4. To help visualize the authentication flow, either DHIPv4 or v6 can trigger authentication. The first thing that our Radius platform does is check to see whether we've toggled or we've configured MAP-T on that BNG, which we have now. Our entire BNG estate in the UK supports it. So the next thing, it'll look for that DHIPv6 option 95. If that doesn't exist, it'll look for the DHIPv4 option 60, or do a regex match for that string I mentioned. If either of those exists, then it'll look for the disable profile. If that doesn't exist, it checks to see whether that customer should be opted out to 1-to-1 or whether it should use the shared 8-to-1 profile. CDN sharing can be a bit more problematic in this IPv4 as a service world, or indeed any even traditional carrier grade NAT world where your IPv4 topology no longer aligns with your IPv6 topology. So we have CDN caches distributed quite deep into our network, down at those satellite pots. We'd obviously want to, in a happy path would be to steer IPv6 eyeballs to those closest CDN caches. But if we were to steer IPv4 eyeballs to the same CDN caches, packets will get tromboned back up centrally via the border relays to get translated and then come back down again. So some CDNs use the source IP of a DNS query to make their steering or mapping decisions. This has historically been the source IP of the recursive name server until eDNS0 client subnet, or ECS, has come along. And what that does is it embeds the original source IP of the client into the DNS query payload itself, so that the authoritative name servers can make more informed mapping decisions. This still doesn't help us for our current use case, though. So what CDNs and authoritative name servers need to start doing, in my opinion, is to not just look at the ECS or source address of the query, but also the query type itself. So is it a quad A query for v6, or is it an A record query for v4? But that's going to take a while for the CDNs to catch up, so we've had to do the logic for them. We have 6 sites around the country where we anycast recursive name servers from. We're only anycasting the v6 VIPs for these MAP-T clients, so all DNS queries for MAP-T will get delivered over v6 to our recursive name server platform, where the recursive name server will do that logic. It will check, is it a query type, is the query type for a quad A? It'll insert IPv6 ECS value like normal. If it's for an A record query, then it will do an internal lookup to work out the MAP-T IPv4 address that customer is using, and it will synthesize and insert a v4 ECS value instead. So now the happy path, we can steer v6 clients to the local CDN cache, but we can make a different decision and steer the v4 clients to a centralized CDN instead to avoid tromboning up and down. We now have a vested interest in making sure as much of our content is v6 as possible, so both of our flagship video products now support IPv6 from QS31, which has been released earlier this year. One of the other problems ISPs complain about is not having a lot of CPE support for MAP-T, which is absolutely true, but that landscape's changed quite a lot recently. So we're lucky enough to build our own in-house CPE based on the open source RDKB software stack, but OpenWRT's got a pretty good solution, even the problems aside that I mentioned before, still pretty good. Kinetic, these guys were really proactive. They reached out to us after we launched in Italy and they developed their own support. And Fritzbox has very recently, actually, in the last few months, released in the mainline software tree now, actually. It was in the lab version a few months ago, but now Fritzboxes support MAP-T out of the box, which is great. And TP-Link and Zixel apparently also do it as well, but I haven't been able to verify or test those. And then, yeah, wanting to end on a bonus slide. During our trials and testing, we found that DDoS attacks will come in. They'll often use fragmented packets or other types of malformed packets, which will hit our border relays. And because they're malformed sufficiently, they'll just get thrown on the ground. So, yeah, bonus DDoS protection built in that we didn't even think about. And that's it. So I think ending on Q&As if we have time, or this one. Yeah. Do we have, do you want to do a mic or anyone Q&As or next? Oh, first time I've had no questions. Okay.
Well, I've got one for you then.
Okay.
You mentioned some exception traffic.
Yes.
Back on one of your early slides.
Yep.
And you mentioned fragmentation was one of them. What about other IPv6 extension headers? Do they end up in exception traffic, or does everything handle it nicely?
Short answer is probably, you're probably right, that's probably going to be exception header. Well, actually, sorry. Actually, no, hang on. V6 doesn't go through this at all. This is just V4. So right. because V6 is within the domain, you're not going to see the extension headers, other than the, well, yeah. Oh, sorry. You almost caught me out there. William. Oh, do you want the mic? Yep. Yep. Oh, sorry. Sorry, I didn't on David first.
Thank you very much. You mentioned that the CDNs had to follow your path of implementing IPv4 and IPv6. I have two questions. Do they follow? Do they all follow? And what is about the implementations of other service providers? Do the CDNs have to implement several ways of knowing that you have different infrastructure for IPv4 and IPv6? Because I see the next problem in implementing IPv6, you just go one path, and they have to follow, and then another provider has another path they have to follow. Are they willing to follow?
Yeah, so, I mean, my personal opinion is I think the CDNs should be looking at the query type. I think they're the ones that are making the topology and the mapping decisions. They should probably acknowledge the fact that the V4 networks no longer align directly with V6, and I think they should probably adapt. The method that we've done, and we've implemented that logic for them in our recursive name server platform, is a bit more, I guess, transferable. We don't need them to do that, so it's a bit more transferable across all of the CDN vendors. We still need to have the ability to have multiple topologies and map them individually. So there's still a little bit of nuance there. Yeah, so arguably, other people may want to do what we did and just not have to worry about individual specific CDNs supporting it.
So it's better to do it in your own network than to rely on the implementation of the CDNs.
Yeah, I mean, I was trying to make the CDNs do it, and then someone was like, "Oh, let's just do it ourselves. And I thought I came around and agreed that, yeah, it's probably just easier if we do it and more, yeah.
Thank you.
Oh, sorry, let's come back up to David.
Hi, Richard. A question. So you mentioned you're doing load balancing using L3 information only. Have you tried using flow labels?
Sorry, I missed the initial part. I heard the flow labels.
Yeah. Have you tried to use flow labels as an input for load balancing?
Have we looked at using flow labels for balancing? No, we didn't. No. The short answer.
Just one quick question. You said about proactive opting out of 8-to-1 to 1-to-1. Have you done any analysis of what kind of percentage of subscribers you expect the proactive monitoring to trigger that for?
So before we did Italy, we did a bit of analysis. We tried to look at using the ACS platform, TR69, work out how many people were doing UPnP port forwards and all that sort of stuff. The original CPEs we had UPnP turned on by default, so we couldn't really gauge how many people are going to manually turn on UPnP. In the end, we kind of estimated or budgeted for about 5% of opt-out. That turned out to be quite high. We are in the UK now looking at just over 1% of opt-out. So anyone who intentionally turns on UPnP or does port forwarding or DMZ.
Oh wow, a lot lower than I thought.
Yeah, me too. So yeah, good. Oh.
Yeah.
Oh, sorry.
Pete from Mythic Beasts. The slide behind you is a one-slide summary of why everyone should deploy V6, isn't it?
Sorry, the slide behind?
The slide up there is a one-slide summary of why you should deploy V6, because it looks a lot faster to me.
Yeah, serve content via V6. Great.
Yeah. So for me, just to conclude, so how many people are staying on the old stack? How many people are going through MAP?
So,
or how many are just, what's the proportion of traffic you see now? Has the V6 gone up?
V6, the ratio of V6 hasn't got up as much as I thought it would after we've turned on support for Stream and Glass. We've still got lots of legacy video devices, so that's artificially driving the ratio of V4 higher in our network, which hopefully will change over time once people move. The ratio of customers with MAP-T and dual stack, we made a decision not to retrofit the old devices with MAP-T. It's just going to be on the new Sky Hubs. So that will grow over time. It is growing. But yeah, it's going to track linearly the launch of the new CPEs.
That's great. Thank you very much, Richard.
Thank you.
Thank you.